Hello everyone. Today we will continue our grillage modeling from the previous session. So please load your model.
Okay, next step is to define the diaphragm members. In this bridge for abutment and pier diaphragms, I will use an I section. Also for the intermediate diaphragms, it will be a steel frame composed of angle sections. So right now I will define the diaphragm section for abutment and pier. We can define it as a custom WRF section. So shapes, WRF. I'm going to add one here. The name is diaphragm pier abutment. Same name. Steel material. For D, 1500 millimeters. Nominal the same. B1 is 200. T1 is 20. B-do same, 200, and T-do 20. And W, the thickness of web is 9.5 millimeters. So if I check the member the section, so the D is 1500, B1 200 is okay, T1 20 millimeters, B2 200, T2 20, and W is 9.5. Okay, so I've defined the diaphragm member for pier and abutment here. Okay, now that we define the section, here we need to add the members here. Because the members are located in the middle of these girders and their center line will be located here, so we need to add some extra nodes here, and these extra nodes should be connected to the beam, the main beams or girders. So here what we can do is use copy and paste. So I'm going to select these nodes, 1, 2, 3, 4. Also we will have diaphragm members here at the pier and here. So Control C, I'm going to copy them on a Y direction as minus 910, minus 0.910, which is half of the height of the main beam. Okay, Control V. So to see things better, I'm going to deactivate the 3D display for now. Okay. So as you see, these are already selected, but they are not supports. They are just simple nodes. So press Ctrl H, or go to node mode, press Ctrl H, and change them to normal ones. So we have the normal nodes here, and we will use rigid members or rigid links to connect these nodes to the girders or main beams. So addition, okay, member addition, and here I will connect this node to the beam using rigid links, and here it will be fixed, and they are not depend on the stage. Okay, same thing here. Okay, and for the other nodes. Okay, so this is the same rigid nodes, rigid elements that we use for these members. Also, we need these rigid members here on the pier. So add rigid, and everything's okay. For this girder, okay, and also for this one. So right now, the extra nodes for the diaphragms are connected to the beams. So same procedure for the final span here. I turn the model to have a better view. And connect this. Okay. And finally this one. So the rigid links are defined, and right now we can add the diaphragm members on pier and abutment. So go to add member from this node to the other one. They will be standard. The section will be steel. And as you see here, we have already defined the section, the custom section. It's here, okay. Steel. G403580, and they will have the steel dead load. We want them to be designed. And your standard. Also for their steel design, I will use the same code. Connections are fine. Okay, so the diaphragm is added here. So we will continue with the next one. Okay, and here. So we will add the diaphragms for pier here. And here. Okay, you can even hide the floors to have better view. So just select the members and mask them. So right now the floors are hidden. And finally we add the diaphragms on this side of the bridge. Same section, steel, standard, active design, steel design, okay. Click the nodes to add the member. Okay, so right now I will define a selection for these members. So select them. And this one here. Control L. So I will name this selection as pier abutment diaphragm. Okay. Right now, if we switch to 3D display, you will see the members here as the diaphragms on abutment and pier. The next step that we should do here to have more realistic supports here, I'm gonna move my supports to the bottom of the girders using the rigid links here. So if we deactivate the 3D display here, okay, and select just the members, mask, okay. So I'm going to shift my supports to the bottom of girders here. To do that, we need to just select these nodes. Also here. And here. And copy them. Same number, minus 0.91 meters, and it will be the bottom of the girders. Control V, so they're here. I will define them as supports. So select those. Control H, define them as supports. Okay, and we can match the properties. So I select one of the supports here, match properties, and click on these new ones. So as you see, the properties are matched. And right now, we can define these supports as normal nodes. Okay, so I have new supports. at the bottom of my beams. We need to just attach these supports with rigid links to the girders. So add member here, change it to rigid. Okay, here it's fine. Rigid member fine, okay. So it's defined, and also for the other girders. Now I have new supports just under the beams. So we can do the same procedure here. So select the support, the nodes. Define them as supports. Okay. Match properties. And change these nodes to normal ones. Replace normal. And now we can add the rigid members. Okay, for the middle beams. Okay, and finally and for this side of the bridge, same procedure. Support. Match properties. Define these nodes as normals. Normal node. And add the rigid members. Okay, so if I turn to 3D display here, as you see, the supports right now are placed at the bottom of each girder, which is more realistic. We save the project. Next stage is to define the intermediate diaphragm frames. So we will define them in each 8 meters along the bridge. So to start to define, we will define it for one of the spans, and afterwards we can copy and paste them. So we will select 4 nodes here in the span of 8 meters. So each of these are 2, so 1, 2, 3, 4. So here the first diaphragm will be placed in this span here. So I select these nodes on the main beam. Mask. and we will build the diaphragm using these 4 nodes. So firstly, we need to build these vertical rigid links, which models the web of plate girders. So first thing, we need to copy these nodes, y direction, minus 0.2. I'm going to add a distance of 200 millimeters between the slab and starting coordinates of the diaphragm frame. Okay, Control V. And after that, again, Control C, copy these nodes here. The height of diaphragm will be 1.5 millimeters, so here will be minus 1.5. Okay, Control V. So these are the vertical lines for the frame, and all of these will be connected to each other with rigid links. So we can add the rigid links right now. Rigid, okay. Okay, and we can use the copy and paste feature. Control C, X direction, 3 meters distance between the girders. Control V. So I have the vertical members for the frame diaphragm. The horizontal members here will be angle sections, so add members. I'm going to use a hinge-to-hinge connection for those. There will be standard. We want to design them, and the section will be steel angle sections of 89 9.5. Okay, the material will be steel. Activate design. So here everything is fine. Connection. Steel design sticks, and other default values are okay. So this is the angle member. As we already explained before, you can rotate this member using the beta angle, but for this project, I'm just leave it like this. So this is the other span here, okay, and here we have the same member bottom. Okay, and to have an extra node here between this, in the middle of the bottom frame member, we can divide them to 2. Okay, so I have an extra node here to attach my other braces. So add from here to here, same member, okay, and here, okay. So as you see, I have built the frame for my intermediate diaphragm. These are these rigid elements, and these are the angle sections. To check the end conditions, I will activate this option here, end conditions, and as you see, ends of all members are hinged. And here, as you see, I have the continuous member. Yeah, they did steel, and steel design is defined. So next thing is to copy this along the bridge in 8 meters distance. So I bring back the whole structure, go to the 2D model one. I will hide the floors for now. Mask, okay. Select the members. The vertical ones, and also the small ones here. Okay, so Control C, Z direction -8 meters. Okay, and Control V. As you see, the frames added here. Press again Control V. So I have my frames here added. Here. And ADA automatically will merge the nodes here. Control V. And here I've reached the pier. So here we need to define it as 16 meters. So I hit Control C again, or select the members first. So I'm going to use the restricted window. Okay, looking from top, restricted window, select the members. Okay. Control C, -16. Control V, so I have it here. Top view. Restricted window, select members. Control C, -8, and paste. So as you see, I've defined all of the diaphragm members. And if we turn to 3D view, you will see that the diaphragms are defined here between the girders, each 8 meters. The next thing that we need to do is to define a new selection for diaphragms also. So I go to top view, select the diaphragms, or frame members here. You can either use this method, or if you just want to define a selection for L members or angle sections, the easier or much easier way is to just select all of the members, Control H, and here, as you see in the shape, we can just select the angle members. So clicking here, ADA will sort, and if you roll down, here you see we have L sections, so I'm going to select these L's only. This is the spreadsheet ability of ADA, which helps to also select these members or sort them. Click OK, and as you see here, only the L sections have been selected. So press Ctrl L, and I'm going to define them as angles. Okay. So whenever we want to select them, we just go here, click angles, and they are selected. Save the project. Now that we have defined our geometry, we have defined the sections and materials and everything, we need to define the loads and load cases. So we have already defined the steel and dead load. I'm going to define some other loads here. So the first one will be the deck. And it is a 6 cast concrete. Next one is the asphalt. That's bearing surface. Barrier. Prefab components. I will define a form workload. As a prefab component. And also a live construction live load. A 6 it will be live load. But this one I'm not going to use it in load combination generator, so I deactivate it here. I will add it to my stages afterwards. Okay. Next step is to apply the loads. So I select the frames or floors, Control K, floors, mask them, go to load mode, and we can start defining the loads here. So for example, for asphalt, it will be a distributed load on the floors. Control H, distributed, add, okay, the load is minus. We need to select the floors first. Control H, okay. So it's distributed, and I replace those with minus 2.10 kilopascal. Projection will be global. Okay, so it's applied here on the floors. The next load is a barrier. The barriers I will apply just for these edge members here. So I'm gonna select those here and here. Control H. Replace minus 2.47. And global direction. Next load is construction live load, so it will be applied for all of the members. Control H as minus 3. Replace global. Okay. For the deck loading, select the members. Control H. The deck is minus 5.7. Global coordinates. Okay, the load is applied, and you can see the values here. For the formwork, again Control H, minus 0.5. Global. And for the steel, as you know, because it's already defined as automatic here, so ADA will calculate it automatically. Okay. Next step is to define the stage construction load combinations. So the first one will be stage 1. It's the construction stage. stage 1. We have stage 2. Stage 6. And stage 7. And to apply the load factors, so here stage 1 will be the steel, at stage 2 we will add the deck and formwork. Stage 6 will be asphalt, and stage 7 let's add the barrier. Okay, so we have defined the stage load combinations here. The other step is copying these as ultimate to have design results, as I've already explained to you in previous sessions. So I changed the name, just stage 1 verification, stage 2 verification, stage 6, and stage 7. And I will define these as ultimate. To have the desired results. And for stage 2 here, we can add also the construction live load. The load factors, this one we can change for 0.85 or whatever number you want to define there. Okay, so check the load cases again. Definition. So as you see, they're defined here stages. Okay, and now we can use the load combination generator from ADA. So it will be according to a 606. We don't have any moving loads yet, so here everything's okay. Add. For moving loads, I will remove this one here, no seismic loads here. And these are the load combinations that ADA wants to build. Next, here you have the load combinations. And clicking finish, you will have them here. You can always check the factors from this menu. Okay. So as you see, ADA have already applied the dead load from steel on the members, diaphragms. You can check for the angles also. So as you see, ADA already applied the their dead load in still load case. Save the project. So we will make sure that everything is defined for the members. So it's still design for the angle members, still design. Okay, so right now we can do the analysis and design. So I will click this here, analyze. ADA starts the analyzing and designing for stages. Close. So check for the load combination, and we see that everything is okay, no errors. To see the design results for beams, we can just select these beam members, go to view options, results, design load rates. Okay, and as you see here, the results for design. Of course, in this model we don't have any moving loads yet, so it seems conservative. In the next sessions we will add moving loads to this structure. You can check the design results for angles. So if you go to selection, Control K, select the angles. Okay, mask them, M. So these are the design results for frame members. You can have the detailed report by clicking each member and clicking this report here. So this is the design preview for that member. Also, you can check for the moment diagram or shear diagram if you select just the beams here. Okay, go to the view options, and if you want to check the MX diagram, click OK. Select your load case here or load combination, let's say for stage 1, and increase the size of the diagram or scale. So here, as you see, we have the results for moment for stage 1. You can check the results for stage 2 also. And also, if you want to check for other results like shear, the diagram is here, and the deflection for the main beams. If you double click on the member, you will have the full results, the deflection and other internal forces. So also you can have the stress results. So if you just select one of the beams here, so you can go to select the beam, results, load combinations, stresses. So here you see the stress results for all of the section or all of the members here. This is the length of the bridge, and use the sigma, and you can check it here for all of the construction stages. This is the results for steel section, and you can have them for slab also. As you see, the number for slab is too small. And in stage 1 and 2 we don't have any slab, so you can have bending moments here for stage 7, let's say. Trying again. Bending moments, yeah. For stage 1, 2, 6 and 7, and also you can check for the deflections and any other kind of results that you are looking for. Okay, so this was a brief session on modeling 3D grillage bridge with grillage modeling. We have started with a single beam, and afterwards we built the grillage model 3D based on that beam. We added the diaphragm members and load cases, load combinations, and finally doing the analysis and results based on sticks. So if you have any questions on the modeling, please let us know with this email address here. Just send us an email, and thank you very much.